Okay, we're going to begin 7.3, which is hypothesis testing for the mean. Now, this is when we have the sigma unknown. So, in our last section, sigma was known, so we used a z-test. Now we're using a t-test because our sigma is unknown. Okay, as we go through this, keep in mind, a lot of times in class, you guys correct some of my mistakes. Hopefully I didn't make any in here, but if I did, feel free to ask me, text me on Remind or something. So in this section, we're going to first find critical values in a t-distribution. Then we're going to use a t-test to test a mean when our sigma is not known. We're going to talk about this using a couple of different methods, p-values and critical values. Okay. So like we've talked about in other sections in chapter 6, a lot of times you're not going to know a population standard deviation or a sigma. So in those situations, you're going to need to use t instead of z. Again, we still have to have a normally distributed population or an n that is greater than or equal to 30. But those are the same as the z-test. And then when you're looking for critical value, whenever you use your t-chart, remember that our t-distribution uses n minus 1 as its degrees of freedom. Okay, so make sure when you're using your t-test, you keep that in mind. Okay, so, sorry, one second. Technical difficulty. Okay, we're back. So for a t-test, when you're running a t-test, it's just going to be in stat, calc, and that's going to be your t-test. So stat, calc, it's right under the z-test. This is what you're going to put in. We're almost always going to be in the stats menu because we're going to, most of these problems in this section are going to give you a mean and a standard deviation. Remember, if you get a list of data, then put your data in that one. But usually it's going to give you the already calculated X bar and standard deviation. And your output is going to look like this. So remember, you're going to tell it what your alternate hypothesis is. Then it's going to tell you a t, a p-value. These are the two things that you need off of these output screens. One thing to keep in mind, a t-score is always going to be rounded to 3 places. And a p-value, just like last section, always 4 places. Okay, so keep those things in mind. Maybe make a note of that somewhere. Now, for the next couple of things we're going to be doing, you are going to need a t-chart. So if you don't have one out right now, maybe pause the video and go either get one out of your folder or from a PDF that is online. There, you can just Google for a t-chart, but if I remember after this, I will also post one on Canvas. So go get a t-chart from wherever you're getting one. Okay, so for t-distributions, again, obviously if we have a calculator right in front of us, that's great. But there's a couple other ways we can run t-tests. So for t-distributions, you can also use the t-chart. Now, we're not going to talk too much of this because this is not a really great method. When we talk about using the t-chart, it's only going to give you a range of p-values. It's not going to give you an exact p-value. So that's an issue sometimes. Now, let's say hypothetically that our alpha is 0.10 and you use your t-chart and you find out that your p-value is somewhere between 0.025 and 0.05. If that's the case, then you would know you're rejecting your null. It doesn't matter if your p-value is 0.025 or 0.03 or 0.04. When your alpha is 0.10, it doesn't matter. Now, let's say the same scenario, but your alpha was 0.03. If this is your scenario, you're not going to know whether or not you're rejecting or failing to reject your null. So as far as how we actually get this, if you want to ask me that in one of our Zoom sessions, we can absolutely go over it. But again, it's not a method that I really like, so I'm going to kind of stay away from it during this presentation. Now, what we're going to talk about next is the critical region method. So we talked about critical values and critical regions in 7.2. It's, remember, when we have some kind of boundary which forms a rejection region. Okay, now with a T, it's slightly different in how you find that boundary than it is for a Z. I actually think for T, it's easier to find the critical value, so hopefully you do as well. So on the next slide, it's going to tell us how to do that. So again, you're going to want to have a T-chart out. So on that T-chart, you first are going to look at your alpha level and talk about how many tails you have. So at the very top of your T-chart, you're going to have 3 rows in bold. First one is level of confidence. We use that in chapter 6. Second one says 1 tail. Third one says 2-tailed. So depending on what kind of test you're running, let's say you're running a left-tailed test. So that is a 1-tailed test. So you're going to go to the row that says 1 tail. You're going to scroll over with your finger to whatever alpha value, 0.10, 0.05, 0.025, etc. You're going to go there. You're going to go down with your finger in the degrees of freedom column. Remember, degrees of freedom is n minus 1. Now, when you find where those places meet, you're going to see a number there. Now, if it's left-tailed, even though on the chart there's no negative numbers, all of our left-tailed tests are going to have a negative sign. Just put a negative sign. If you look it up and it says 2.681, but you know it's left-tailed, make that negative 2.681. For a right-tailed, you just use your 1 tail, you look it up, and you use the positive number that's there. If it's a 2-tailed test, you go to the 2-tailed row, you find what's there, and then it's both a positive and a negative. So if you see the number 1.706, it's going to be positive 1.706 and negative 1.706. Remember, for a 2-tailed, you're going to have 2 rejection regions, one down on the left, one up on the right. So your left-tailed, you're only going to have 1, and it's going to be negative. Your right-tailed, you're only going to have 1, it's going to be positive. And your 2-tailed, you're going to have 2. Okay. So now, take a second on these and try these 2 problems. So the first one says find a critical value for a left-tailed test. You got alpha is 0.05 and n is 21. Make sure you make that degrees of freedom. To get that, you subtract 1. Okay? And the next one says also left-tailed. Alpha is 0.01 and n is 14. I'm going to give you the answers here in a second, so if you want to try them yourself, make sure you pause the video. Okay. So we have negative 1.725 for that one when we are at degrees of freedom, remember, would be 20. And then alpha is 0.05, 1 tail. And in our next one, we're at negative 2.650. Okay, again, if you didn't get those, maybe pause the video here, try and figure out what you did wrong, make a mark on it in your notes if you have any issues finding those. Okay, so example 2, very similar, except we are dealing with right-tailed tests. So let's think about what that means and how that becomes different. So we're doing a right-tailed test this time. N is 17 and our alpha is 0.01. And then another right-tailed test where alpha is 0.10 and n is 9. So again, take a second, do those on your own first, so then you can use my answers to check them. Go ahead and pause it here. So your answers are 2.583 and 1.397. I bet you can guess what's coming in next. It is your two-tailed test. So now we're doing two-tailed tests where we have alpha is 0.10, n is 26, another one where alpha is 0.05, n is 16. So try those. Remember, these you're definitely going to have plus minuses in them when they're two-tailed. Okay. So your answers are plus or minus 1.708 and plus or minus 2.131. Okay, now how are we going to actually use these to make decisions in t-test? So we're going to do 4 examples coming up. Now for those 4 examples, we can either use the critical value method or the p-value method. I will discuss both as I go through these. So again, I know some of you guys like to write, and it helps you to write down the steps. So again, how do you know when you're doing a t-test? So first you need to verify that your sigma is not known, your sample's random, and then still, just like before, your population is normally distributed or n is greater than or equal to 30. Just like in our other sections, you're always going to start with your null and alternate. You're going to make sure you know what your alpha is. Now, for steps 4, 5, and 6 here, we are going to do that. That's what we just did on the last 3 slides. But you can also use a p-value to make the decision. But if you prefer this method, write down this formula here. So you have t equals x bar minus mu over s over radical n. Very similar to our z formula, but with an s instead of a sigma. Okay? So, again, if you want to write that stuff down, you can pause it. But again, some of you won't be using these steps 4, 5, and 6. The homework, I think, will make you use those at some point, though. But when you run a t-test on the calculator, you can kind of bypass 4, 5, and 6 and use a p-value instead. But we're going to do both ways. Okay, so we have example 4. A used car dealer says that the mean price of a 2-year-old sedan is at least $20,500. You suspect this claim is incorrect and find a random sample of 14 similar vehicles has a mean price of $19,850 and a standard deviation of 1084. Is there enough evidence to reject the dealer's claim? So we're going by the dealer's claim, not our claim, using an alpha of 0.05. Okay, so again, before you do this problem, make sure you know what we're looking for. We're looking for a null, an alternate, our t-score, our p-value, our decision, and our interpretation. Now again, when we're talking about the p-value here, you could also do the critical value instead, that t0 that we just talked about on the other slides. So one of these, critical value or p-value. I'm going to do both, and you can decide, but I think your homework is going to do a mix, so you got to make sure you know how to do both. Okay, so at this point, take a minute, try the problem again. If you're on your calculator running a t-test, but the answers are all coming, so pause it if you're not ready. So, for this question, the dealer was claiming that the mean price was at least, so we have to make sure we know what at least means. At least means greater than or equal to. So we have, sorry, I'm going to erase this. This is confusing me. Okay. Okay, I'm getting this back. All right, so we have at least 25,000. That's what they said. The alternate to that would be less than 25,000. So again, running a t-test in the calculator gave us these two values. Keep in mind here that our alpha was 0.05. Okay, so that's what, when we compare our alpha to our p-value is less than our alpha. Remember, when your p-value is less than your alpha, you're going to reject your null. Now, since our claim was in our null and we rejected it, that means we have enough evidence to reject the claim. Okay? Now, let's say you just hate p-values. Ew, I don't like these. And you would rather use the critical value method. So if you're using the critical value method on this question, remember our sample size was 14. So our degree, I'm going to erase that because that's something's going to pop up there. So our sample size was 14. Cool. All right, I guess we're leaving that one dot there. So our sample size was 14, which means our degrees of freedom was 13. If you look up your degrees of freedom as 13, an alpha level of 0.05, you end up with, I can't write here. You end up with a critical value of negative 1.771. Remember, when you're doing a left-tailed test, like you are here, because of the less than and the alternate, that gives us a left-tailed, so it's always negative. Now, if we think about that on our picture, negative 1.77 would be about here. That means anything less than that would be in our rejection region. And our t-score was negative 2.244, which puts us right around here. So that also leads to a rejection. Now again, your conclusion from this, your critical value, must also match your conclusion that you made with your p-value. So we're all good there. All right, so another example. It says an industrial company claims the mean pH level of the water in a nearby river is 6.8. You randomly select 39 water samples, measure the pH of each. The sample mean and standard deviation are 6.7 and 0.35 respectively. Is there enough evidence to reject the company's claim at alpha is 0.05? Assume the population is normally distributed. So just take a few minutes, pretend you're in class right now, and I'm just waiting for you. Maybe you're talking to a friend, maybe you got a friend on FaceTime. You guys are watching this together. But take a minute and do this problem. And then here, again, pause if you need to. And then the answers are here. Okay, so they said the pH level was 6.8. That was their claim. The complement of that is not 6.8. The t-score from the calculator was negative 1.784 with a p-value of 0.0824. Our alpha, again, was 0.05 here. So when you compare our p-value to our p-value is larger. When our p-value is larger, we fail to reject. And since our claim was here, if we fail to reject, again, we're not accepting it or proving it, but we're like, yeah, all right, looks okay. If our null, if we weren't able to reject our null, that means we were also not able to reject our claim because those were the same thing. If you're finding the critical value, your critical value is plus or minus, since this is a two-tailed test, 2.204. I'm sorry, 2.024. So that would be over here and over here, which means our rejection regions are less than 2.024 and greater, sorry, less than negative 2.204. Oh my gosh, I can't say that number. Less than negative 2.024 and greater than positive 2.024. I think I've said this number wrong like 6 times, but that number right there. So our t-score that we got was negative 1.784, which puts that, I can't see my lines anymore, somewhere around here. No, sorry, somewhere around here. Whatever, but not over here, okay? So it's not less than our negative 2.024. So it's not in our rejection region, so that leads us to fail to reject, just like we already decided with our p-value. Again, you don't have to do both methods, but it's kind of good to see if your answers match. Okay, so for the next few, I'm just going to kind of let you do them. I'm not really going to go that into depth, into detail. I'm just going to let you guys read the problem and try it on your own and give you the answers. If you have any questions or if you think I did something wrong, just contact me on Canvas or on Remind. Okay, so here's our next one, our critical value. Again, we failed to reject the null. We would be right around here with the critical value. and our t-score wasn't even 1 away. So we were failing to reject our null. And this one, our claim was in the alternate. So when we failed to reject our null, we were unable to support the claim. Okay, and the last one, again, I'm going to pretty much let you do it on your own, but there was one thing I wanted to point out, and that was here in the problem. So again, take a second and read the problem, pause it if you need to. But the one thing I wanted to point out was this at most. Okay, so at most, we need to make sure we know what these type of terms mean, like at most, at least. At most means 18 is the most, which means we are talking about a situation where we are less than or equal to 18. So that's the claim that's being made there, and since it has equality, it's going to be your null. So make sure we know what phrases like that mean. Again, answers are coming. Pause it if you want to work on it. This one had a really high p-value. If you notice, our t-score was way over to the left, but this was a right-tailed test, so we weren't even close to rejecting here. Our p-value, our critical value was negative 1.796, so we're right around here. And, oh no, wait, sorry. That's wrong. See, I found a mistake. Our critical value should be positive 1.796 since this was a right-tailed test. So that was a right-tailed test. So let me erase that line I made right there. Okay, so let's make that, oh, that's not what I wanted to erase. Sorry, guys. I'll get this at some point. Okay, so our critical value was positive 1.796. And let me erase this line. Okay. So our critical value was positive 1.796, which puts it right around here. And our rejection region would be this region over to the right. And then our T was all the way down over here, definitely not anywhere close to our rejection region, which means our null is looking really good. We can't reject that. And that kind of makes sense, because if you read the question, it says they claim people are not waiting more than 18 minutes, and the sample had a mean wait time of 15 minutes. So it definitely looks like it's a good deal less, especially it's more than 1 standard deviation away in just that small sample. But yeah, we're definitely not rejecting our null here. Okay, so that is the end of 7.3. Again, if you have questions, please feel free to contact me on Canvas. And then, yeah, do your homework. Make sure you do your homework.